Welcome to Graph Power Hour. This is episode number 3. Thank you all for joining. And we're delighted today to have with us our guests, Chia, Jeng, and Thomas Smoker from WhyHow.AI. Chia and Tom, welcome.
Thanks so much for having us, Paco. Excited to be here. I'm one of the co-founders of WhyHow, and we build data infrastructure for structured knowledge representation. We focus on a number of different verticals like legal and healthcare and finance, with legal being one of the main focuses for us at the moment. And we very much enjoy seeing how structured data can bring more explainable, more deterministic reasoning and information retrieval processes to enterprises. And so my background is as a ex-founder and operator across different spaces, and also with a legal background. Over to you, Tom.
Fantastic.
Cool. Hi, everyone. My name's Tom. I have an Australian accent, if you can tell. So I often have to justify my academic credentials very quickly. But I did my master's in electrical engineering, PhD in computer science, specifically in knowledge graphs and knowledge graph embeddings, but more broadly, reasoning and natural language processing applied to physical industries like mining and oil and gas. But kind of pure in philosophy in AI, and I've been in this world for a long time. Went from there. I was an academic for a while in and around that world. I then went into large-scale businesses, building and maintaining, large-scale machine learning, graph systems, etc. I've been in the graph world for about a decade, which at this point I think makes me quite qualified. But it was not cool for a very long time. I was shouting into the ether. So it's very cool that this is on Paco. It's great to be able to connect with the broader community. I think she has justified our company well, but I'm happy to get into some questions and specifics.
Definitely, I'd love to dig in more. One of the things that we were mentioning about when we were prepping, I would generally ask like what kind of conferences and all you've been at lately. Although I was looking back and it was like, we've actually been speaking at we've been involved in so many of the same conferences. I think you all, between, Chia, Tom, also Chris Rack, shout out to your other co-founder. Between the three of you, I think you've been at almost every event that I've been at in the past year. So I'm really glad to see your representation throughout this community and all your contributions to this. And like you say, graphs, even just a few years ago, it was hard to get people to talk about it. And now suddenly we're front and center in a lot of the AI discussions. So one thing to lead out then, I'd like to dig in and understand a bit more about your company and kind of like, where you're positioned, like what sort of range of capabilities you have, because as I mentioned, amongst the 3 co-founders, you bring in a wealth of expertise and experience.
Yeah, absolutely. So we started out building just a bit of history of the company and kind of why we exist and what we're trying to solve for. We started out building a number of RAG systems for folks a couple of years ago, and realized really quickly, I think, what a lot of people who work with Senzing or listening to this podcast probably understand, which is that, hey, the data structures that we're trying to utilize with embeddings and RAG are not sufficient to get the type of outcomes that we want. And so we started realizing that if we were able to structure data in a particular way that fits the business use case, that fits the context that we're trying to optimize for, we're able to get these systems in a more deterministic kind of flow. And so we started building a lot of infrastructure that we felt was native to how LLMs worked, how LLM workflows work, and really tried to reimagine kind of what would all of this look like if it was a lot easier. And so we open sourced a number of different tools, including the entire backend of our knowledge graph studio that is designed to help folks create structured representations. And so alongside that, we have a number of open source tools. We have a cloud hosted platform, and we also do quite a lot of white glove services and implementation and architecture design for a number of different clients who are trying to adopt graphs and trying to adopt graphs, especially in the context of LLMs. And so that intersection of structured representation and LLM systems are something that we have spent the past couple of years really, really diving down on. And because the team does come from a range of different industry backgrounds, legal, healthcare, finance, it's also been pretty helpful to be able to very quickly kind of ramp up to the kind of use case the clients have been optimizing for. And so we've been helping them in a pretty rough way, if that makes sense.
Yeah, that's fantastic. Yeah, Tom, I didn't. I don't
Oh no,
know.
I should yeah, just to add some context about the graph stuff just quickly. Sorry, Paco, you have much more intelligent questions than me, but to that point, I was part of a research group, and specifically we were in a competition for knowledge graph creation automatically in 2018. It was a conference called CIKM, or a large data science conference in Beijing, and so I've been doing knowledge graph creation at the time. It was with Roberta and Bert. And so we actually won that competition, which was cool. But I've been in the create a knowledge graph with AI world for now it's 7 years. I've been doing this for quite a while. And so it was useful to have that background, especially as we started to get in the explainability and as things like, LLMs accessible via API really took off. So we've been doing this, for a while. And I think you have just as much context as me, well, more context than me. But yeah, graphs were one way to do things for a long time. And it definitely feels like there's a spotlight on it now.
Yeah, I mean, there's this whole umbrella of hybrid AI approaches, probably more recently being called neurosymbolic systems. I know there's a conference coming up at Santa Cruz, I think, NASIS. So, I mean, we're starting to see this hybrid approach really emerge and get shape. But this idea that we can take graphs along with machine learning models and come up with more robust solutions downstream from that, this is the thing that's really catching on, and GraphRag has been driving it. But I'd love to dig into it more because I certainly have some takes, definitely some opinionated takes on how to tune that. Although I think that actually you've found other areas that are very useful and very much counterpoint to some of what I've been looking at with LLM. So I wanted to explore that with you. Like for instance, there are a number of different tutorials or vendors or whatever that will say, just throw all your data into an LLM, we'll generate a graph for you. It's all magic and everything will be great. We work a lot in cases where there's accountability that's required, explainability, as you mentioned, where if you are working in healthcare or legal or some of these kinds of verticals where you must show how you arrived at the result, having a magic black box give you all the answers is not really going to work. So I've been interested in how to deconstruct that whole thing. How can you take and build out workflows that have good point solutions? But I think that you all have some interesting counterpoints to this, because I've been trying to back away from LLMs, but I think that you've found really good ways to harness them. And I'd love to explore more about what you found and how your approach and your thinking about this is. And I mean, we can talk, I don't know, maybe we could start out looking at the range of verticals. I know that you all have some, there's a number of articles that are on Medium have about different implementation patterns. Are there any generalizations for AI apps that you're seeing emerge across these different verticals, or could you help to characterize what you're seeing across these different patterns?
I'll start. I think Chia has a really good way of explaining this, so I'll go first, and then let's see what we get to. But a point I'll make, again, just about the previous point I made about the graph competition, is that I was part of a research team. That broader research team was Professor Wei Lu, Michael Stewart, Najiga. It was a team of people all working towards building some sort of general knowledge graph. And these are professors I've worked with, very capable people, all just trying to build this graph, right? So the implication then that you're going to build a graph with one shot since then, I think is tough. And she has a great article that we all stand behind, which is one-click graph creation creates bad graphs. Now, there's use for bad graphs for sure, but we're not in the business of necessarily selling them. I think there is a prototypical stage that is useful, but for us, to the point of the medical transcripts, and you and I have been through this, but we have an end-to-end case study describing that process that we go through. We use some synthetic transcripts. We transform it as we need to. We evaluate it as the clients that we work with need it. We gave the idea that it was 25 dev hours just to build out the structured representation, build that together. That 25-hour number is not generalizable, to your point. It's indicative of the one process that we went through. But I think because we've detailed our learnings as we went, it is not a process of AI's made this easier. I've been building large-scale graphs for a long time. It is 1,000x cheaper and faster than it was. that does not mean it's one click, I think is the point that you've made. So I appreciate you bringing that up. Chia, I'm not sure if you want to speak to verticals more, but otherwise I can go through this, kind of healthcare case study that we have.
Yeah, maybe I'll say a couple of things and then love to go to the case study. So I think, Paco, to your point, I think graphs have been very much adopted across a range of different industries now. I think CodeGen has seen, widespread adoption of graphs when it comes to being able to navigate code bases and dependencies, etc. And so I think everyone's starting to realize that if you have a very powerful LLM system, and the way I think about LLMs is it's a very smart intern that needs a lot of guidance and direction and guardrails. And, that's what structured representations really are. It's just a set of guardrails. And I think one of the things that we've talked about before is how, guardrails are similar to checklists, and checklists are similar to how all professionals really work. You have a checklist in your head. It could be a sophisticated one, but everyone relies on some kind of guardrail, no matter how smart you are, and you have that in your head. And so there's two very interesting things that we are seeing when it comes to guardrails and graph structures and those similar kind of structural representations. And the first is really around information retrieval and RAG. And that's obviously the popular thing that everyone's coming around to, and enterprises obviously adopting RAG. And so it's top of mind. And it's fairly obvious where structural representation works in RAG and all these systems. And to your point, it helps to bring some level of auditability when it comes to citing sources, when it comes to all types of things like that. There are also applications when it comes to analysis. And so in finance and healthcare, and also in the law, the way that we consume information and then process the information in a particular way that adheres to, for example, the way that the legal contracts document structure is formed, or being able to ensure that when you're looking at someone's healthcare record, you are also taking into account these 5 other documents that are related to the patient's medical history. Or if you're looking at financial factors, being able to make sure that you have the complete picture before you're making a financial analysis, statement, or evaluation. And so all of these are pretty key aspects of what structured representation means. So we have structured retrieval, structured analysis. And I think that the piece that's also really exciting that we're starting to see much more and more, especially as we recently trained a DeepSeek model on a very specific type of reasoning for a very specific industry niche, was that reasoning itself requires some type of guardrail. And there are plenty of industries, especially if you consider the fact that there's no objective truth to reasoning. We can see that in certain domains, math, engineering, there is an objective truth. There is an objective answer that can be verifiably, that can be verified. There are certainly many other domains, especially in the humanities, and that law is a very easy example where there is no truth until somebody, a human, decides what is the answer and judges on that basis. And so you see a lot of different types of reasoning that you want to be able to engage with the model to help enhance reasoning processes. And things like DeepSeek has really started to unlock some of that imagination when it comes to the adoption of automated reasoning within systems. And so being able to inculcate your version of reasoning into systems is also something that we've also seen graphs really be very, very helpful for. So we're doing a lot of work just really trying to push the limit of what structured representation mean and can apply for systems. I'll pause there and hand it back to Tom.
Thank you. I'm not sure if there's anything you want to go through, Paco, but otherwise I'm going to kind of jump into it. Now, conscious that this is, at least partially an audio medium. So I'm going to jump into an article. I noticed James in the chat has, kind of brought this up. Thank you. But any article I go through, we're going to have links. So again, they're all accessible. If you want to follow along, you can. But for those watching, which is usually me, I'm just going to share my screen. And I'm just going to go through with practical examples, kind of the case study I'm talking about. Specifically, I'm going to jump to this medical transcript. So I'm talking about first. Again, this article is available. And to the point of this this conversation, at least to the title, it's around temporal, right? And for context, my primary supervisor during my PhD, Tim French, who's fantastic, said you can work on whatever you want, just don't work on temporal stuff. So I'm very, very aware, and he is fantastic at what he does, but he's very much in the logic and the representation world. And I think that when it comes to temporal reasoning and any sort of spatiotemporal understanding artificially, I think that's a very difficult process. So I do want to stress that this is an approach to understanding and using temporal information. Temporal reasoning in itself is not a solved problem as far as I'm aware. But I want to go through exactly what we did. So this is the article I mentioned before, and it's a case study of what I went through. And again, I did this primarily, so I can talk to it in detail. I'm going to talk to the data set we used was from Senzing, a fantastic team who's been working on promoting completely synthetic medical records. So all the PI is removed. I use 75 transcripts. What it has is a variety of patient histories. And so I turned it into this conversation, got a conversation on the screen around what would be indicative. And I want to stress that we worked with clients who have this data. This is an example of it. I'm obviously not going to share PII or any of the work we do with our customers, but for the sake of this, I think the process is demonstrative. And so what it comes down to is first, when you get this information, you have to define the schema of what you're working with. Now, where there is some sort of innovation here is that the schema is going to be twofold. So the first is going to be there's a high-level graph schema. And by the way, Paco, if this at any point gets too boring, carte blanche to butt in. But if at some point you're going to get a schema. Now, the detail of the schema does depend on what you'd like to. Whether there's external reference, specifically this one uses FHIR, FHIR, which is fantastic, but that just happens to be the ontology that backs this. But a lot of what we're working on here is the specific graph structure at a high level, so at the ontology level. I'm just going to jump my screen into what this graph looks like. This is on our platform specifically. So if you see here, we actually have the graph. And for those listening, just to talk to it, I have a patient has an encounter. So I have a patient and encounter type. Patients can have condition. Patients received immunization. Patient has measurement observation. Now, this is a very basic thing. I don't want to. I want to stress that there's data levels. I know that there's potentially more interesting schemas. However, this schema did get us what we needed to. And part of the reason there is that what we do with our graphs, and I'm going to jump to the screen again, is we specifically have chunks. Now, the term chunk has been thrown around a lot and can mean mostly the same thing, which is split your textual data at a consistent point. There's a bunch of more intelligent ways to do it that are very necessary. But what we ended up doing, and part of this is born out of necessity, was saying some of the data that I deal with these patient records is going to be too hard to extract from or too inconsistent to extract from, such as like various parts of short text. What I'm going to do is just make those chunks. So then what the graph acts as is basically an indexing layer. So I have an ontology. I then have the instance data. So the patient's name, for example, or the immunization they received. And then I have text chunks associated at a lower level. So when I query the graph, and how we do it is we embed the triples with the metadata and then can bring that in through natural language. When I query the graph, I can also include those chunks. Now, if you see here, the description is basically, okay, the chunks will have like a summary of event, key points mentioned. I've got some examples here, but what you can see is that those chunks have timestamps. Now, there is questions around duration, there's questions around how consistent, et cetera, et cetera. What I will say is that for the sake of this example, for the customer we were working with, this answered their temporal questions in a way that was scalable. Because what I effectively have is for each patient, I have like a Rolodex of their events. And so effectively you can just go through, and by the way, these chunks have metadata on them. That metadata can be a date object. That date object is searchable. Everything we have is through an SDK, so is everyone. So use whichever method you want to search on dates. But that Rolodex of events can then be brought into a context window, for example, and then can be summarized such that you can ask questions around and here's an example of a patient history, but I'll just scroll down to the specific sort of questions.
May I ask one question then? So
Please.
This is something I hadn't caught previously when we were talking about it, but are you saying then you could be looking at queries where within the context window, you're pulling out based on a date, that way you can get a confluence of events that are happening within a certain range? Is that one of the approaches that you're taking?
Yeah, so this question is, the natural language question as given and the answer as given. We have all these linked. This is explainable as well as much as you want. Again, we have this graph here that you can see, pretty densely connected, to be honest, with the way that it's built. It's demonstrative. Real world data can be made this dense if you want it to. I'd say in practice, it's not as much. The Synthea team's done a fantastic job at completing all of these records. To that point, yes, you can ask questions. I mean, look, a simple enough hack is just put a datetime.now in the in your prompt and you can get today's date, and then you can start to do questions like that. But to that point, yes, what is the sequence of encounters? I can get that accurately. And then how many patients have been diagnosed? I can give specific dates. But what I can say is like earliest onset dates. I can say what happened in the past 2 months. So this is an example. What type of well-child visits and immunizations did Joseph Corona, who's one of the patients, again, fully synthetic, fake person, receive in their first year? So I have answers like born here, it's currently this date, therefore his first year is here, right? And so then I can actually literally limit. Now you can do this through an LLM if you trust it. Frankly, when I did this experiment, I was impressed at how well the LLM did it. And that was not with the API access of O3 and DeepSeek and various models that we have now, Poison. But I'm impressed. Like, obviously, we have guardrails around those metadata filters for chunks, etc., all accessible by SDK. But to that point, yes, the LLMs are quite good once you give them the accurate context. And I'm able to give them the accurate context because I've stored those chunks as, again, I like to think of it as like a Rolodex. I basically have all these index cards for each process. I'll pause there again. This article will link. I have a bunch of examples like this, but I like to think this explains it well. And just going back to the point before when I said 25 hours, that's this one. And a lot of that is figuring out, and this is an iterative process, this sort of process, which is at a high level, patients have encounters. So this is what the triple looks like. And then what do the chunk IDs look like? And what's an example chunk? So what do I choose to make as the ontology? What do I choose as instance data? What do I choose as that? And to Chia's point before, when you start to choose when it comes to things like legal, financial, maybe those sort of like, more qualitative sciences, that choice has a large impact and is not to be underestimated as a decision.
So a couple of questions in it to try to summarize some key points here. One is I definitely heard a really good description of the decision to chunk because you can't, in fact, extract every final little detail out of the text reliably. So essentially, you make some trade-off by having the raw text chunk there. What is your experience working in these different verticals? What do you see as far as like a chunking factor, or how do you arrive at that decision of like where to make that trade-off?
You're right. Yeah, actually, what I'll do, just for the sake of progressing, I'll jump to another case study we have, and this is one where I specifically have used, and I actually really would like to talk about how Senzing benefited me here. Senzing is fantastic at what they do, which I can get into specifically, but just to show that this is a consistent process across domains. This is a similar example of congressional reports. These are PDFs, they're publicly accessible. Here is again an example of a very basic, very, I like to think, accessible ontology here. And then each of these become chunks. But what I have here, as you can see, I have some specific context and I have like some sort of description here. Now, when it comes to the decision, I like to think that this, and I'm gonna use this word carefully, but at least for me, because I've been doing this for a while, this actually makes it easier, not harder, because it is often clear what has to be. And by the way, this is the chunk ontology here, for want of a far better term. But I think it makes it easier because things like a hearing, discussed topic, people participated in hearing, people affiliated with organization, you can see how that's relatively easy. Once it starts to get like to go down to this process, hearing has summary. It's like, well, what is a summary then? Because I can tell you definitively what an organization is. I can kind of tell you what a hearing is, but what is a summary, right? What's a financial insight? What is a challenge? And it's like, you can start to define these things if you want, but especially like to the point of this and to the point of the medical thing, I can't really back up challenge with an ontology right now. I can back up organization with an ontology. I can back up people. There may be different ontologies to describe it, publicly or otherwise. But when it comes to those questions, it's like, well, I do have some fuzzy information. Like, this is useful as a chunk type, and that is what matters as a type, right? Now, what matters is at every congressional hearing, there is basically like this kind of key insight section, right? And it's like, well, that is particularly useful to give to the LLM because arguably that is the most concise bit of relevant information for that document, right? I would like to give that to an LLM at query time. However, what matters is difficult for me to define consistently as a triple. So I don't have a better call other than it's a judgment call, Paco, and I'd say this is emerging, so I don't necessarily have it. Plus, it goes across domains, but I've actually found it easier. I mean, this emerged from our own process of solving this problem for a particular customer, which is that, well, if we can have specific things, and by the way, each of these nodes can have properties. I might just jump in here and show this is what the congressional report looks like, by the way, in terms of graphs. And what you can see is that we have all these kind of mini graphs per congressional report, but we start to get these subgraphs emerge and we start to get these connections. And so we start to be able to query across. So I'll jump back to just kind of spoil the ending here. Where we seem to get, by the way, this is that, the data came in as JSON files. Specifically, I have things that Senzing improved. I will go through this. Duplicates of individuals, being able to resolve that. Yep, this is just super useful. I'll jump into the graph and show again how, especially when it comes to things like congressional reports, resolving individuals, resolving organizations, resolving locations, etc., is all of the necessary context I need to give an LLM for questions such as, and by the way, in this article, I gave all of my prompts, all of the process, all of it's in an SDK. This is all accessible if you'd like to replicate it. Again, even the articles, so this is literally replicable for sure. But a question like this, tell me everything Congressman James Comer has been involved in the past 2 months. I can get an answer like this, right? Because first of all, it's going to embed and find the most relevant triples to James Comer, right? Now, when I first started with this data, he was not a congressman, right? Because as much as he was, that information was not present in the particular congressional report. That information was present within Senzing. So then I can start to consistently name that entity. And then I can pull in all the relevant information from that consistently resolved entity. And I can start to then, get some temporal information, which is when I say in the past 2 months, and specifically when I questioned this was a little time ago, but to that point, I can see specifically which hearings he was in, statements and articles. I can get what matters from each. And I can also get the consistent people he had. I can reference the specific sources. And how this is possible is because of the tiered approach of going from high-level structure ontology, instance-level data, properties on each of the nodes of that graph. And then for each of those nodes, I then have this Rolodex of, okay, now that I've identified that James Comer is in hearings, which hearings should I bring in based on that time?
Right.
And then I can start with those questions here.
So what I'm hearing here then is, I think also an important point to bring out to the audience, especially if people are approaching GraphRag or trying to understand where applications are. We've got some different elements. We've talked about ontology. We've talked about entity resolution. We've talked about the analytics involved in graphs over and beyond, say, the information retrieval. When people look at having, a mountain of PDFs, like you've got thousands of congressional transcripts, but as PDFs, we will talk about these as being unstructured data, but in reality, there's an expectation of structure, right? These hearings all have some kind of structure that is implicit in how the report is supposed to be made. And the ontology then, it sounds like, is that providing an expectation of the structure that you would expect to find once you parse it?
That's a great question. Like a really good, thank you very, yeah. So what I'm going to say first off is, again, I did a lot of literal academic research in knowledge representation in this way. And supervisors, Melinda Hogowitz, Tim French, Wei, we're all fantastic. This is not a fully legitimate process. I want to stress that this is not end-to-end research. I really want to stress that this is problem solving using the tools that we have available. Yeah. To that point, yes, it informs everything. It is not start to finish. I actually think that if you start with an unstructured document, that is a blanket term that we rarely gradiate, right? Because some documents, whilst unstructured, I actually have a legal document example here that I can go through, which, so this is a particular example that we went through, which is we called recursive retrieval. And it was to the point where it's like, okay, well, in this legal contract, if I bring in this chunk, that chunk references paragraph 5.2, right? But that paragraph is now necessary context. So where do I find it, right? So then I have to go back and then find that location in that area, right? So you can see in this diagram, and this is I can go through this at some point if you want. Again, public Medium article. This is a multi-agent system we built to go and specifically figure out when I'm reading a legal contract, I need to make sure that the necessary context is there, right? So this was useful, but you can also see with this document, right? This is a contract. You could make a pretty strong argument that this is structured. This is arguably more structured than a lot, like in terms of relevance, arguably more structured than some CSVs you get, right? Because they're just like exports from a program that has a bunch of unnecessary information. This is like a numbered, structured, document that we can actually access. Take that back to a different PDF that's like, a think piece by a very relevant writer, which is entirely unstructured prose, right? They're both PDFs. They're both unstructured information. They have an entirely different ontology and a level of structure. So to your point, I think that when you start to design these processes, such as I have to figure out, okay, I have this, which seems very basic, but was not first pass. That's iterative, right? And then within each chunk, I actually have described each chunk. I think I need to know what documents I'm dealing with to be able to build this. I think it would be naive to build this and then apply it to any document. And this is part of what we try and stress when it comes to these hours and why it takes time, is that it's often tailored. You can definitely inherit from ontologies such as FHIR, such as SNOMED when we work in the medical use case. Like there's a lot of ontologies that are fantastic that you can inherit from. But I will say that to your point, it is the constant ongoing process is juggling. I want to get an answer in a structured way, right? I want to give structured context or some sort of structured grounding to an LLM to summarize for a user. And that structured grounding has to be consistent from the data that I get, which may vary, right? So absolutely. I don't have a great answer here in terms of like that it's easy or that it's solved. What I will say is it's a consistent iterative process throughout.
This is the work. Interesting. And granted, yes, this is not research. This is very, very pragmatic, because if you've ever been in a position of having to understand some legislation in progress and all the drafts that a 900-page document might go through and what the legal implications are for your organization this week, it's mind-boggling, and it's a nightmare.
Yes.
And it's happening at scale across the world, EU, US, etc. So it strikes me that this is eminently practical. But I'd love to hear your thinking about like what are some of the practical kinds of applications that would come from, I mean, just focusing, say, on the legal example here.
Yeah, I'm not sure. And again, I'll stress that Chia has a legal background, so I think he can talk to legal stuff very well. But what I will say is that we work with, especially lately, a lot of legal clients. And I think that he made the great point earlier in that there's actually a lot of structured legal data. However, there's a lot of unique legal workflows. When I was working for my PhD, one of my supervisors, Melinda Hogkowitz, who's fantastic, but has a great background in maintenance and engineering maintenance and structured engineering work, especially when it comes to, we were able to reference standards, like literal ISO standards, right? It would be hard to standardize a legal workflow. And I think that's where there's a lot of interesting opportunity, but also difficulty when it comes to this expectation. So when it comes to like specific legal work, I'll go through this example again. This is the kind of graph that we built from that contract. But where this is particularly useful, you can see that this is more of we call it recursive retrieval. It's more of like an intra-document. Like you can literally see, these are kind of the nodes that we have around this process. All of these kind of policies that are necessary. But the legal work that we have here is the recursive retrieval, is that like we need to specifically go and get that information to the point of questions. And again, we have full experiments here. If we want to ask questions such like, I mean, there's a lot that we can go through here. I'll try and go through the specific one. if we want to ask questions around what are the CIO responsibilities, right? And this is a contract that defines them. You can see in here, the benefit of us being able to structure this contract in such a way is that we can reference where it came from and make sure all the necessary context was built in. We're calling it recursive retrieval. We've called it that for a while. I think like the recursion element, is interesting, especially, but most of that really is if we naively chunk this, then we're not going to get all the context we need. In fact, any sort of references might be the most important bit of information. And so that's just like very necessary context to build in. We need to structure this. By the way, this came from Reducto. If anyone's curious about how we were able to analyze the PDFs here and specifically get the bounding boxes and get the literal information. But again, all details, we've got a repository out you can find that information on. Chia, I'm not sure if there's a further context you wanted to add legally, but at least for me, I think this was a really useful kind of aha moment for us that we're able to bring in the necessary context through several passes of arguably reasoning.
Yeah, so I think, Paco, your question was really about, hey, what are people using this for, right? Practically, if I understood the question. And yeah, so the long story short is there are a lot of scenarios. We're releasing a whole bunch of pretty exciting updates over the next few months in terms of kind of very specific tooling here. But high level, the problem in legal, which interests me a lot, is that there is data that is structured in a way for humans, right? And you can think of footnotes, you can think of clauses that refer to other clauses as a big part of that. And it's a very kind of unique type of document structure that you don't really see in other industries as commonly. And so a lot of what we're trying to do is really map the way that documents are structured and the way that humans and legal professionals read, interpret, and draft these documents in such a way that reflects how it should be understood, right? Like, and traceability and auditability are very large components to that. So one very trivial example is, hey, when you assess, when you gave me the answer for the question earlier, did you consider, this one subclause as part of it? Right now, it's very hard to show that, right? It's also very hard to show that there was a reasoning process there that did take into account that one clause as opposed to the 50 other clauses that were part of the analysis. So that auditability component, I can completely imagine you have systems that could get you the right answer through some sophisticated multi-agent system alone. It's considering this and that, but you lose the ability to showcase that reasoning process, which is really important for lawyers because they need to be able to know that, hey, like, yes, this answer sounds about right, but did you consider all the relevant facts, right? And the joke is I saw this IBM quote from the 1970s, and it said, no machine can be responsible for the actions it takes, so no machine can make a management decision. And lawyers are very much like that. You need to put someone's head on the pike if something goes wrong. That's what lawyers are there for. And so if they can't explain how something works, it's the value really goes down for them, as opposed to someone else in a different industry where there's potentially different dynamics. So we see a lot of auditability needs when it comes to the legal use cases. We see a lot of data that's really semi-structured on my very specific definition of semi-structured here, that people would like LLMs to take into consideration. They don't. And so a lot of the infra is really not built for that, right? A lot of the infra, if we think about general industries, are really more for, hey, how do we digest 50,000 documents at once? And if we get a 98% accuracy rate, like, that's great, right? That's a fantastic result. But that's absolutely not what some of these professions in this niche needs. And finance, healthcare, legal tend to be a little bit more paranoid about the fact that, hey, like, I have a very specific reasoning process. Please take that into account. And I prefer you to be accurate on 10 types of documents as opposed to 5,000 at once, right? And then being at 98% accurate on those.
Well, I'd love to dig into more about the reasoning aspects. One quick aside, you do mention in the article here about the the hearing summaries of using entity resolution, could you describe just real briefly, like where did the entity resolution part come into this?
I might even specifically, I'm going to show you if that works, just because I think the visual works really well, at least for me. And again, I'll talk it through as I go. So I'm just going to share my screen really quickly to show you where it was very helpful. And like, because I just have a really specific example. Again, I use Senzing for this resolution. I'm going to go back to that, this case study specifically around the congressional transcripts and asking questions about those. Here's an example. I'm just going to go just to organizations. I'm going to scroll down to see where I can. And I'm going to show you that if I go along, you can see, and just for the, listen, I know it's a smallish screen, I'm going to zoom it right in. There's the Center for American Progress and the Center for American Progress Action Fund, right? Those are two distinct organizations, if you want to look them up. But there's an implication there from their name, just at a high level, that those are very similar, at least subsidiaries, right? Now, for these congressional reports, they can't be treated that way. When I did entity resolution just by semantic association, just using some Python programs, these were resolved to be the same entity. When I use Senzing, they're not, because they are specific different entities. One's a think tank, and one's a policy institute. And that's particularly useful for me because when I then specifically get to the fully connected graph, when they're being used as these entities, right, then I can make sure that I'm referring to the right thing because they have different individuals, they have different organizations, like all of these things here, any of the resolution that I want to do. Now, what I'll also say is that individuals can be resolved together because when it comes to congressional hearings, sometimes only the role of that individual for the sake of the hearing is described. When I went back to James Comer before, like how he is relevant to that hearing is his role. If I use something like Senzing, like some sort of external resolution software that I can leverage, I can get all of the roles for that node. So when I ask further questions about him, instead of it being like, hey, there's James Comer, the representative, and there's James Comer, like I get all of the context in one process. Now, I keep using the word context because those are two examples. One is where the context wasn't complete. The other is where the context would have been incorrect. Both of those are very important when it comes to giving context to an LLM because I'm just going to stop sharing. When it comes to an LLM, if the context is incomplete or the context is incorrect, unless the LLM has been trained on that information, the LLM does not know, and it will respond as if that information is complete and correct, right? And so then at that point, it may confidently give you an answer that is wrong, and that is something that we're trying to avoid. So when it comes to explainability, when it comes to entity resolution, those are the things I need to be constantly aware of, which is inconsistent, incomplete. How do I resolve that? Now, I don't know all of the roles that James Comer has, and it is unscalable for me to go and find them. However, using some sort of entity resolution means that I can immediately resolve those. I'm already working in JSON a lot of the time. Senzing works super quickly, works locally, so that's why it was particularly useful for me. And then I don't have to work, like I have that as context. So yeah, sorry, Paco, please.
Oh no, that's fantastic. Thank you. I know that there are some questions in Q&A coming up too about this. So yeah, Steve had a question here, especially for medical record use. How do you capture and reflect the progression of diseases over time? For instance, perhaps early in an instance, a detection test might come back negative. Later, a condition worsens. Positive test would result. This would probably also apply in epidemic modeling.
Yeah, this is a great question. I appreciate that, Steve. So any sort of SAR modeling for this process, like any sort of simulation, I think is harder, and this is like the panacea of any sort of temporal reasoning. However, to your specific question, this is actually something we can do because I'm sharing my screen. But when it comes to the metadata on each of those chunks, they actually have a high-level class. For example, is this an immunization report? Is it inpatient? Is it outpatient? And then it actually has the specifics about the results, such as positive or negative. Now, it is going to depend on how clean and dirty your data is, I will say, or how complete that data is to that point. But this information, to your specific example about like a detection test might come back negative, but later it comes back positive, we can answer that question because I will have the report dated in the past, which is negative, with the type of test, and then I'll have the report dated in the future relative to that older report that is dated positive. And in my experience, LLMs can resolve that. But if they can't, again, there's multi-agent systems you can build. We're getting better and better reasoning mechanisms. Regardless, the data at the ground level is there. But it is a great question around any sort of SAR modeling. I've done a lot of that specifically in and around this process. Again, when I used to work with agents and planning and knowledge representation in my academic career, I think this is a very useful tool for this. What I will say, oh, sorry, Paco, please.
No, go ahead. No, please.
There is an interesting question here that I will say is a difficult challenge, which is something we do consistently work on, which is most knowledge graphs are either time independent or point in time. The implication of SIR is often time, like some sort of continuous time scale, or I guess discrete time scale, if not continuous, around how have things progressed over time. I would say that's harder. There's different ways around it that we've had, and a lot of that comes down to multi-agent. Part of why we have so many graphs in our platform is I've done several more discrete processes where you consistently like version a graph, and then you can bring back that reference when you need to. And then you can actually look at the delta between those discrete timestamps graphs and see the difference. And the benefit of having structured representation there is that there's a specific, like I can capture just the diff of that process. But I'm not going to say, again, I'm standing on the shoulders of brilliant modelers there, and that's a way to do it. But thanks for the question.
Oh, fantastic. I would love to dig in more about this point of reasoning. You brought this up. My take is on a lot of this discussion is, I think in GraphRag, maybe 80% or 90% of what I've read about GraphRag, it's information retrieval. We're basically trying to pull up enough chunks and then summarize some answer, and so you've got to chop up this question answer. But I believe that there's much more road ahead in terms of AI applications downstream from graphs, from these kind of processes. So I'd love to hear more about your take about using multi-agent and digging into this kind of recursive sense of reasoning.
No,
I
sure.
could talk about that all day, but I'd love to hear your perspectives.
Yeah, I might just, Chia, just for the sake of it, and she's got some great thoughts on this, but I might just create a delineation at the moment around types of reasoning. There is popular reasoning models right now. They are arguably statistical reasoning or associative reasoning. I come from a more traditional symbolic reasoning world, and I think there's some great work. Ideally, we're doing some of it, but there's some great work around neurosymbolic and what does it mean to combine those two worlds. But I want to stress that, like, when it comes to reasoning, symbolic reasoning, when it comes to like knowledge graph completion, knowledge graph consistency, any of those sort of structured representation and reasoning work, we definitely do some work on that. We can get graphs to like iteratively improve themselves around knowledge graph construction. But I think when we talk about reasoning now, when it comes to like statistical reasoning, comes to like DeepSeeks and your OpenAIs, they're definitely statistical reasoning, and they're both very useful in their own ways. So I'm going to stress that, like, when it comes to when it comes to the retrieval from graphs that you refer to, I don't see many people outside of the academic community using symbolic reasoning in graphs. I definitely see people using graphs for context of a reasoning flow. And to get to that point, that is kind of what we're working on. Now, when it comes to reasoning flows, again, I think Chia mentioned we recently kind of fine-tuned DeepSeek. If anyone's interested in understanding the reasoning flow, Unsloth recently just put out a fantastic article around how they have broken down and how you're able to fine-tune these reasoning steps. And a lot of that is, how does the model statistically process and think? And Paco, to your point around multi-agent systems, look, there's a lot of work around multi-agent systems historically. I'd say at the moment, a lot of how we use it, there's definitely orchestrators and specific tool use, but it's really sequential functions that take an output and then take an input and respond with a different process. Now, you could argue that specific input and specific output is what something like the think process in DeepSeek or the reasoning flow you can see in the OpenAI models, you can see that it is stepping through a process. And that process is either fine-tuned into the flow itself or can be recreated in a multi-agent system. Establishing that structure, Chia, I might hand it over to you if you want, otherwise I can handle it around the reasoning that we're working on specifically and the reasoning that we're excited about.
Yeah, for sure. I interpret the question as like, how do you think about thinking about reasoning in the context of everything that's going on in the world, and especially when it comes to advancements in the infra side. And there's a bunch of things that I think keep us busy and what we think about, and hopefully that gives a sense of kind of what's interesting to us. We think that reasoning can be expressed in a number of different ways. And I think one of the issues with reasoning is that ultimately the customer only cares about the outcome and that the outcome is explainable. And that's, I think, quite different from some of the conversations that we sometimes see between infra builders. in that, that there is a range of different positions you could take about how symbolic or non-stochastic the reasoning has to be. And sometimes those positions get spirited. And we we are very much on the side of making systems that work and making systems that our clients want. And that's the boundaries of all we care about. And so when it comes to things like that, we see that there are many ways to sometimes skin the cat. There are multi-agent systems that you can build in a very complex way that, some people would argue are completely suboptimal, incredibly messy, opaque. And there are also ways where you can have completely symbolic systems that can also, bring about reasoning processes in a completely auditable, transparent way, but taking extremely long time to build out your symbolic systems. And so we spend a lot of time trying to say what the middle ground could look like and what is the most efficient way to get to a level of certainty that the customer wants. And that frequently means utilizing a lot of hybrid approaches. And so that's what we spend a lot of time focused on. And that, I think, is something that at least our customers so far seem to have appreciated. And so very rare, given we have 2 PhDs in knowledge representation on the team, the history of what some neurosymbolic systems look like, very much see that as part of the future, because people are starting to stray and be a little bit wary of all of this. I think DeepSeek, for example, obviously not a symbolic system necessarily, but showcasing chain of thought trails is something that people appreciated, right? And so there are very core elements and philosophies that I think the graph will has to offer to the world and to clients, and we are very much here to help with some of that adoption, if that makes sense.
Fantastic. I'm curious. I mean, we were talking earlier about the process you arrive at of tuning an ontology for representation based on the data that you have. Are there considerations as far as if you do have a multi-agent environment downstream? Are there special considerations you have to have maybe different portions of ontology or different representations?
And this is a great question, because we deal with it a lot, and I'm going to give 2 perspectives. The first is like demonstrably yes, because what an ontology can do is maintain consistency across the multi-agent system, right? And so sometimes it can be some of the existing ontologies are, I would argue, suboptimal for these systems, because like a lot of the why I really like building a multi-agent system isn't necessarily to extend the functionality, it's to contain the functionality such that you can very much like audit the input output, you can test things. When it comes to building scalable software systems, having a small process that only does one thing is very useful, right? Because I know exactly, we have points of failure, we have routes, etc. It's very useful. To that point, how much of the ontology does it need to see? And most likely it's like not much, because if you give it access to all of the world's information, but just by extending the analogy, all of a sudden now it's completely confused. If you give it access to 2 nodes and an edge, it's like, well, it's going to follow that pretty strictly. So it's a useful process there. I'd say that coordinating is definitely useful with a high level approach, such that maybe you have an orchestrator agent and it can make sure everything's being consistent, and it can make sure terms mean the same thing throughout, because otherwise you can propagate the uncertainty. I think I've used this example before, but I'm standing on the shoulders again of brilliant decision-making under uncertainty researchers around, like, if you have a 95% accurate system, just like a RAG system, which to be honest, it's quite a large ask these days, stack 5 of those together in sequence, you've got a 77% accurate system, and that's a problem, right? However, how do you improve that, at least, incrementally and programmatically? And a lot of that would be like, well, isolate it, understand where the problem is, and a lot of that requires the full context. So yes, they can be very useful for that. I'd say it's difficult to build the ontology, because you kind of like a lot of there's brilliant work over the past decades of people representing information in a structured way. However, if you have like a very well-tiered hierarchical ontology, it's like, well, how much of that information does the agent need? And often what the agent needs is nodes at the very ground level in different parts. So then it has to traverse this enormous ontology and add a lot of context that A, isn't necessary, and B, will fill up a context window in such a way that it's confusing. So yes, I think it's great to have consistency orchestrated across your agents. I think some of the existing ontologies, while brilliant for what they do, aren't necessarily built to do that. So I think there is interesting research at the moment. We've done some of it around like, what does it look like to embed and retrieve subgraphs? What does it look like to have, dynamic subgraphs, but consistent high level graphs, etc. I'd say this is an ongoing area of research in terms of like aligning low level systems to a high level ontology. It's definitely something that we work on. I'll say that like a lot of the times, like you saw, once I built that structure in the congressional reports, for example, or in the healthcare example, or in the legal example, once we've built that structure, we've worked with clients such that we understand their flows or reasoning or understanding, and we have it to be updatable to the point by the domain expert. We tend to be able to keep that consistent, and I think that's really important, especially for the explainability. Like if step 4 fails, what does that mean for step 1? It requires a level of oversight. So yes, and then I think I just had an alternative, which would be I definitely think a lot of people get away with not having to do that, and I think these models are showing that there is a lot of access without it. So you can just stack things together, and I think there's ways to immediately find it. I want to stress there's an experimental part to this.
Well, one question that comes to me, and definitely we want to hear a lot of questions from the audience as well, so I don't mean to take up the podium, but in terms of Chia, you were talking about finding the middle ground there. If you do have multiple agents and they're coming out with different perspectives, how do you solve that? How do you combine that into some output? I mean, where does the multi-agent coalesce then down into answers?
Yeah, absolutely. Tom, do you want to go through the architecture for legal rap?
Yeah.
Do that.
Yeah, do you want me to share?
Yeah, thank you.
Yeah, let me jump this share screen, conscious of time. Let's get this going. Yes, have this open.
Great, thanks. Perfect. So, as you can see here, what we've built in this very specific example is a multi-agent system that is designed to do different things. So in a legal contract, as I'm sure everyone has seen a contract of some sort, there are footnotes, clauses refer to other clauses. And so you need to make sure that, and there's also a page for definitions, right? Certain words have a very specific definition that only works for that contract. So we have one agent that is designed to navigate through clauses and be able to bring in information in the context window. We have an agent designed for definitions, bringing in definitions into the context window as it's considering specific things. We even have an agent designed for footers because in the document we had, we made it hard on ourselves, and we in the example, and we said, okay, footnotes are also part of a document, and you need to be able to refer to footnotes and see if that's referring to additional clauses. And in this example, the footnote said refer to clause 5. So you had to, additionally bring in that clause once you looked at the footnote. We did have an agent that is specifically designed to collate all of that information together and be able to assess and create an answer at the end. You can see there's an answering agent at the end of it. In this particular example, a single agent to collate all the information was good enough. I believe we did do a little bit of summarization in the interim. Obviously, it depends, how sophisticated your system is, depends on how complex your document is. This particular document, I believe, was 50 pages or 25, something like that, but relatively small, as you can imagine. You can imagine that if you're reading through a 10,000 page contract, you probably need something a little bit more sophisticated than that. And so the way we consider all of this is, hey, look, we can just use multiple agents to really orchestrate all of this information processing workflows. And then to make one additional point, a lot of what we think about is guardrails, right? I think one of the implications of the questions that you talk about is that, hey, there's informational guardrails that need to exist, and there needs to be agentic guardrails that need to exist. And so you kind of need to be able to have a good understanding of, both how agents work as well as how information works in that particular domain to, I think, be able to build these types of robust systems that work hard. And so graphs are a great way to constrain information. There are also other types of guardrails that we need to be able to consider in these systems.
Are in terms of agentic guardrails? Are the different agents in roles that would be somewhat akin to, say, the roles that people would have in a work group? Like there may be someone who is, I don't know, taking notes, somebody else who's checking citations, et cetera, et cetera. I'm thinking of like an editorial team.
Yeah, it's a great analogy. I think it's a great analogy to especially get like non-technical business leaders to really buy into the concept, and it's definitely something an analogy that we used a lot. The slightly more nuanced answer, sorry, I definitely agree with you, but I think the slightly more nuanced answer I would also add here for this audience would be that, a single person can have multiple different types of workflows. Paco, you do 10,000 different things in your job and in your life. I don't think there's a single agent that could represent Paco. Because, just the sheer amount of people you connect together, and then there's, so many other different types of work that you do. They don't overlap necessarily, right? Paco could be split into 5 different people, and those 5 people would be individually impressive, but they all do different things. And so when we think a lot about workflows, and we use that word a lot because it's very much focused on, hey, what's the workflow that you do? So, myself, I might have 10 different workflows in my life, in my day job, Tom, yourself. And so that's how we think about things and systems. And frankly, I think that's how software works, right? Like software is just the digitization of a workflow. And I think some of the really interesting promises that we have with AI adoption is that it's now possible to map and completely recreate the 10 workflows that I make up. And so if somebody were to put in the work to say, hey, let's try to clone Chia, let's try to clone Paco, it means we need to map out these 10 to 15 workflows, completely digitize that, and that's Chia, right? And so that's actually a lot of what we've been spending a lot of time on, which is, hey, what are the workflows of some of the top people in the space? How do we replicate the graph of workflows that they represent, the graph of knowledge that they represent, and be able to bring a complete digital representation of that person.
All right. Fantastic. I put a couple of links in here. We probably don't have time to dig in much, but I do want to recommend people check out, especially on GitHub. There's a couple of projects here. Actually, if you have time, if you want to go through, to describe about both Knowledge Table and Knowledge Graph Studio. And I just realized that I think that probably my links are not exactly right. Something got munched in my comments, but we'll figure that out in the show notes.
Yeah, no, for sure. So I'll briefly talk about this. It's completely open sourced, and so everyone under MIT licenses, so everyone can go check it out. These are a couple of tools that we have. So the first one is we've outsourced, open sourced our backend for the Knowledge Graph Studio. So MIT license, freely available. Love for anyone to check it out. Fork it, do whatever you like with this. We do support large enterprises with implementation and deployment. So feel free to reach out to us if you have any questions, or ping us in Discord or GitHub accordingly. And so this really showcases a lot of what we talked about, like how it works on the back end if anyone's really interested. The other tool that we've also open sourced is Knowledge Table. And so Knowledge Table is a way to help simplify extraction, especially for multiple documents at once. Again, completely open source, including the front end. And so you can imagine every single row is the separate document and file. Every single column is a separate query for you to perform extraction. You can do a whole bunch of chained extraction. You can also do a bunch of things that are very specific to creating graphs out of the information that you want to extract through the system. And so you can do a whole bunch of things here. And then we also have a lot of data extraction rules and guardrails. According to that, you can see a whole bunch of rules around what must be returned, being able to tag through, etc. It's going to be fairly familiar. I think a lot of different platforms have started to pop up table-based techniques such as this. And so this is something that we open source to the community to be able to use. And you can see that there's an export triples button here where you can turn all the information you've extracted into triples directly and be able to use that in whatever graph database of your choice, including the platform that we've built.
The Knowledge Graph Studio.
Exactly. Yeah.
And very interesting too. I'm very impressed by especially the expressiveness of the rule-based portions of this. Can you describe more about how you're leveraging rules here, or where does this come in?
Yeah, absolutely. So similar, I think, to the problem space that Senzing's in, there is the way that LLMs construct structured knowledge can be fairly arbitrary. And so we want to be able to include a whole bunch of very specific things that are very much accorded to your context, to what you care about. So we have a number of rules here. So including things like being able to ensure you are able to um, return a very specific list of things that you care about, giving few short prompts in terms of what may be returned, being able to allow a certain number of responses, being able to resolve entities specifically. So these are the different types of rules that are part and parcel of this repo and this tool. And this is very much a way to really constrain and allow domain experts to give a little bit more feedback to the system in terms of what they should care about. This is not the only tool that would be required to resolve entities or to constrain what gets extracted, but it's one of the ways to reduce the amount of noise in the data that's being processed.
Fantastic, and they're all complementary there. Fantastic. Thank you, Chia. Thank you, Tom. I know we're past time. I'm super impressed by the range and the depth of all that you're working on here, and I would love to talk for hours and hours, but I know I've kept you already past the time. Thank you very much for joining us here. I put a link in to your company website. Also, what's a good way if people want to reach you? What's a good way for people to reach out?
Yeah, sure. So we have a Calendly on the website, so feel free to book time there. Otherwise, feel free to email us at team@WhyHow.AI or Chia@WhyHow.AI.
Yeah, fantastic. Thank you both very much. Really appreciate it. This has been an excellent conversation, and we'll have the recording up soon.
Thank you very much. Thanks, Paco.
If you would like to get in touch with us and learn more about any resolution, we have a QR code there that has the URL. And also there's a way to sign up for a newsletter. We'll be having more of these usually about every month, maybe even more later on. And I'll just add to, if you want to get a hold of me, we'll be doing more of these. So we'd love to see you here. Please get in touch.